this slide, okay. So yeah, you can find very good drones on the air. So the white and blue color. So that is a very new type of VTOL type of drone made in Japan. And yes, now we are trying every year we are getting and we are trying latest commercial drones, and also sometimes we make original drone too. So yes, today my main work is at university teachers, but another side. So I work with the NPO side. The name is CrisisMappers Japan, and so my name is account name is Map Conscious. Maybe you if you can find this face icon, so on the Twitter, Facebook, or other SNS, so please follow to me. And anyway, so our NPO, non-profit organization side, we are collaborating with student and citizen and government. So, and we can make new mapping community. And also our NPO had many two projects. One is a drone bird, and another one is a Japan Flying Lab. So Japan Flying Lab is a kind of Flying Lab Networks branch collaborated with We Robotics NGO. And also Drone Bird project is a domestic activity in Japan, but we can share our experience and our knowledge to foreign countries. So, and thank you for very good opportunity at this time. So my experience is started since 2011. So many people know. So big earthquake and tsunami happened to in Japan in this year. So and the situation very serious. So tsunami destroyed a lot of cities, and after that, so this landscape happened. So and maybe you can find the ferry on the top of buildings. So that is a very serious situation too. And so in 2011 earthquake and tsunami. So after that, so we went to this affected area, and we brought our drones. So and we take aerial photo data like this, and this data has the same ferries shapes, and also let's zoom. So we can find like this ferry, and also sometimes you can find some object like this. This is a traditional Japanese shrines gate. So maybe that is a very serious situation too. Yeah. So this is my first crisis response using by drones, and my data already we published at on the OpenAirMap. So if you want to find, please search using by this information, and I add the QR code. Anyway, so if you want to confirm, and if you want to show, and if you want to use this data, you can download. And yes, that is my first drones crisis response. And after that, we discussed and we understand we should make next generation of drones mapping community. So we defined the name drone bird. Drone bird means a drone and like the Thunderbird, we combined. Yes, if natural disaster happened, we should to use our drones. And this is a short movie, and maybe
思い出してほしい。大好きな映画。
wait on. sorry, one more. Video, yes. Okay. So this is our drone buzz project short movie. So, and maybe you can understand our activities like this.
もしも大きな自然災害が起きたとき、地図が手に入らなかったらどうするだろうか。そもそも地図がなかったら。
The voice is in Japanese, so I can explain. So our drone buzz project, if natural disaster happen, we can use own drones for aerial photo data, taking aerial photo data. So that is a drone buzz project. And so maybe general drone. Those devices has a camera, and also if we want to optimize each environment situation, we can make own drone using by 3D printer or other data publication tools. Anyway, if we take a lot of aerial photo data, immediately we should calculate also mosaic data, and we should share those data at the public data. And so our project related educational organization, university, high school, and NPOs. Anyway, we should communicate, we should collaborate with younger people, like the students. And they had an interest about drone and mapping. And this is an example in Japan's small island. So Japan has a lot of volcanoes island. And if volcano erupt, so we can use our drone like this. So with local people, we can collaborate. And this is an actual movie taken by drone. So flood, volcano, or landslide, or something. So we can take a lot of data. And so after that, we should share our data immediately. And also, we should calculate mosaic data using by photogrammetry technique. And so those data will support for mapping. The Japanese people, the younger people can use the digital device, and older people can understand the paper map. So we should publish digital data and analog data.
世界中の仲間と連携し、あっという間に地図が多言語に展開される。島民の避難が完了しました。ワーニング、インドネシアのアチで巨大地震発生。ドローンバード、アチ基地より出動。ドローンバードに休まる時はないのだ。
So this is our special movie. So let's back to my presentation. Yes. So, in this year, recently we have 351 drone pilot as community. So this is a recent our drone bot members. So if some disaster happens, so our member will go to affected area. And our process is like this. So we can use our drones, and after that we should make also mosaic data, and we should publish on OpenAirMap and GitHub platform, and after that we can make map data. So, and so example, we can share our example. So 2019, so big typhoon attacked to Japan. So the name is Typhoon Hagibis. So after that, we used our drone like this. So mainly we are using fixed wing type of drone. So because this type can support this type of drone can take very huge areas. So, and yeah, very useful drones. So mainly we are using SenseFly and other companies. And so this is an example data, sample data. So we take those huge area using by fixed wing type of drones. And sometimes we bring to the landslide area. So we have many times we can collaborate with the local government side. So they have some information, and we can collaborate, and we can take a very important point like this. So, and yeah, of course, fixing type of drone. So that type want to use the very open area, so like the riverside or other very big park or something. Anyway, now we are using VTOL type of drone. So VTOL drone can start from the ground to the top direction. That is a very useful tool. Yes. So yeah. And technical side, we should make also mosaic data used by photogrammetry tools, SFM tools. So now we are using multiple tools, Pix4D React, Cloud, and Metashape, and OpenDrawMap. So we can combine. And each tool has good characteristics. And yeah, speedy preview, Pix4D React can. So, and yeah, first we will use Pix4D React as local side. And also, if we take a lot of area photo data as 100, a few hundred or few thousand JPEG photo data, so we should upload into the Pix4D cloud. And also local side, we can calculate Metashape and OpenDrawMap too. So anyway, we can combine, and the goal is we should publish also mosaic data on the OpenAirMap. So maybe you know OpenAirMap maintenance by a hot team, and yeah, that is a very useful tool. And many times we published our data. So, and maybe you can find some data in Japan area. We have over 700 data set on the OpenAirMap. So, and totally global side, OpenAirMap has over 10,000 data set. And so in Japan area, we published over 700 data set like this, and very rough calculation. So we have about 6 percentage is our data. So yeah, maybe that is very huge. So, and now we will extend the OpenAirMap community in Japan too. So, and also not only the OpenAirMap publishing, so but also we should collaborate with the tasking manager too. So you know, OpenAirMap will provide the XYZ raster tile dataset. That is a very useful. And if you published, or if you want to use OpenAirMap data, so you can find copy image URL function, and you can find TMS link, and just one click, you can get TMS tile URL strings. And yes, and also you can make your tasking manager's project. Sorry, in Japanese, but so this is data made by me in last month. So we went to the small island in Japan, and we take a lot of aerial photo data, and we published OpenAirMap, and then we can copy XYZ tile URL and paste at the tasking manager's project side like this. So, and very easy. And we can use tasking manager with our drone map data like this. So we can make, usually we can get about 3 centimeter resolution data. And I want to share about 2 tips about the OpenAirMap. So one, so if you want to log in into the OpenAirMap, recently you can choose 2 selection, but the Facebook login method is not working. So I recommend Google account you can use. So yeah, and also second, so data uploading method. So OpenAirMap has some uploading method, local file, URL, Dropbox, and Google Drive. But I recommend Google Drive is very useful too. So if you want to upload a few gigabyte data set, so maybe local file function cannot work. So I recommend Google Drive. So, and if you click Google Drive's button, and so you have to, after that, you have to upload, before Google Drive's button clicking. So you have to upload your data into your Google Drive storage. And after that, you have to change the permission to everyone can access permission. So, and after that, you can access from OpenAirMap to Google Drive like this. And you can click this data I want to choose, and you can upload. So yeah, very easy. So, and one more thing. So our activity related and based on internet, online situation. But if disaster destroy power infrastructures and internet connection, so sometimes that situation will happen. So we can how to publish our data at the offline situation. We can provide data using by Raspberry Pi. So this is our answer. So now we are making Raspberry Pi device for the drone mapping. So we collaborate with UN side. So UN has an Open GIS initiative, and working group 4 developing UN VectorTime portable device. So, and we can combine vector tile dataset as a map data and XYZ raster tile dataset, and we can copy to the SD card, and we can publish, and we can use offline situation for the those local web mapping server. So like this. So yeah, if you have interest, please join to UN VectorTime Toolkit community, and easy access for everyone you can use. And next year, so we will held UN VectorTime online workshop with hot team. So please join, and thank you.
Thank you very much, Taichi, for that presentation. And hopefully, thank you very much. We have some questions that have started coming in, and hopefully you will answer them in one of the breakout rooms that will be scheduled after this presentation. So next in line for the speakers, we have Ndapile, who will be presenting on behalf of the African Drone and Data Academy. Ndapile, welcome, and over to you.
Thank you. Let me just share my screen now.
Please keep it short and sweet. We have 15 minutes per speaker, so we can have ample time for the next speaker.
Okay. Are you guys able to see my screen?
Yes, we
Yes.
can. Thank you.
Okay. All right. Hello, everyone. My name is Ndapile, and I'll be presenting on drone technology and youth. So I'm from the African Drone and Data Academy, whose main goal is to equip Africa's youth with 21st century skills through drone flight and data analysis. So just a brief overview of myself. I'm an instructor at the African Drone and Data Academy. Also a certified drone pilot with an instructor rating from the Department of Civil Aviation here in Malawi. I serve as a regional ambassador for Youth Mappers under the Everywhere She Maps initiative. And I'm also a co-founder for an organization called Map Malawi. So throughout the presentation, I will talk about my work with these different organizations. So just a brief overview of my work, where Ground Zero started with my work in drone technology. So basically, before I got to ADDA, drones were like pretty new to me, but I was lucky enough to be admitted into the program. So ADDA is a UNICEF-sponsored program which was launched in January 2020. But before that, UNICEF and the government of Malawi were working hand in hand, starting from June 2017. And the ADDA was born as a response to the need of skilled personnel in terms of the use of drone and data technology. So UNICEF and the government of Malawi opened the first humanitarian drone corridor that's located in Malawi. Oh, sorry about that. Yeah, so it's located in Malawi, and its main goal is to just allow local or international drone companies to come and test their solutions in terms of drone technology. And the organizations are aware of how important drones are and their role in helping in economic development and also humanitarian purposes. So in most cases, they would have to have foreign people come in to deal with the drones and pilot them. And then they then recognize that we can do some capacity building here in Malawi and also in our neighboring countries to help build this capacity that we need. So that's when UNICEF came together with 3 universities to come up with a curriculum. So the Virginia Tech University is the curriculum developer and prime contractor. Furman University is the GIS/data curriculum developer, whereas Malawi University of Science and Technology is the local implementing partner, and that's where I work hand in hand with here in Malawi. So the ADDA has 4 unique programs, and we're always targeting the youth because we know how important the youth are for the future. So we have the Certificate of Drone and Data Technology Level 1. We have the Certificate of Drone and Data Technology Level 2. We have the Remotely Piloted Aircraft Technology course, and also the Data Visualization and Cartography. The level 1 and level 2 were in response of the pandemic. Initially, it was one program that would run for 10 weeks. But after we realized that we weren't going to be able to do in-person classes, after the pandemic hit us, we then decided to break the program into 2 levels, where the first 5 weeks would be taken online, and this usually focuses on GIS. So basic, like we take everybody from ground up. We don't assume that anybody knows anything. So we start with the basics of GIS. What is vector data? What is raster data? How to use the GIS software. And as an institution, we are very big on the use of open source softwares. So we're using QGIS for most of our labs in terms of, most of our labs during level 1. So after we introduce the basics of GIS, we now walk people through how to work with drone imagery and the different analysis that they'll be able to do after acquiring the imagery. And then the last week for that 5 weeks program is basically just an introduction on the technicalities and the physics of flight. And then for level 2, you now come in person here in Malawi and you get a hands-on practice. You do the mechatronics of drones, you learn how to fly, and we also have a lab that helps you build a drone from scratch with locally available resources. And yeah, so people learn the components that make up a drone. And this is like, we do this so that people are able to know how things work, right? It would be different if we're taking a drone off the shelf. People won't know the insides. So the goal is to teach people how things work. And if there's a need for maintenance, you should be able to do that on your own. The remotely piloted aircraft technology and the data visualization cartography, those are 2 online courses that you can enroll in, and they're 2 weeks long. So you get the different certificates that I've outlined on this slide. The top level 1, which is issued by AUFSI, and the CDDT1 certificate, which is issued by our consortium of universities. Okay, so thus far, some of the accomplishments, that we've had as an institution are, we've managed to graduate more than 300 youths across Africa in 20 countries. And we're still counting. We're hoping that at the end of the project, we've at least covered each and every country here in Africa. And also we have deliberate policy where we make sure that 60% of our enrollees are females. So this means that 60% of our graduates are females. And this is also just to propel the involvement of women in these different technologies that are trending now. And also after our graduates leave our program, a good number of them go in drone or data industries. Some of our graduates are working in the agricultural industry. So here in Malawi, some of them are working with farming and engineering services. Others are working in the medical supply. So companies that are using drones to deliver medical essentials in clinics that are hard to reach, and also in situations where driving there would risk somebody's life. They instead opt to use drones. So some of the companies that are employing our graduates are companies like Wingcopter, companies like Swoop Aero. And some of them are now in the education sector, such as myself. So after I graduated from the institution, I was then hired as an instructor so that I am in the forefront of equipping my fellow youth with this important technology. And again, our goal for ADDA is to scale across Africa, and how we're doing this is basically training trainers so that they introduce our curriculum in their different countries. So the current cohort that we're training now consists of individuals from Niger and Ethiopia, and those are the 2 countries that we're hoping ADDA would scale to. So basically, the individuals that we identified to be strategic partners have come here in Malawi, and we're training them on how we deliver our curriculum so that when they go back in their countries, they know how to do it. Okay, so after working with drones for quite some time, my partner and I, so my partner Zola Manyunga, decided that we should come up with a project that's able to integrate drones, OpenStreetMap, and other geospatial technologies in solving some of the community problems that are faced. So the project is under Map Malawi, and Map Malawi is a youth-based organization founded by 2 females, myself and Zola. So the Dzaleka mapping project was funded by the humanitarian OpenStreetMap under the Facebook community grant. So the project was basically just aimed to generate geospatial data about the provision of basic needs at the refugee camp by integrating the drones and also OpenStreetMap. So this project came about because we realized that the camp was built to house at least 10,000 people, but is now currently housing more than 43,000 people. So we decided that we make a project, map out the basic needs centers. So we're mapping out centers such as education centers, water points, dumping sites, just anything that contributes to the livelihood of people, we're mapping out so that at the end of the day, we get a picture of the extent to which people actually have access to, say, health facilities or education itself. So we weren't just doing this as the two of us, we decided to also involve youth. The reason why we did this is because we feel like this will strengthen the capability to use the geospatial technology so that they're able to address their communities. Because we believe that at the end of the day, after you equip somebody with the right skills, they're able to now take the skills and implement it into their different issues that they face. Because I can decide I want to do a project somewhere, but I don't intimately know the problem that they're facing as compared to the people that actually live in the area. So capacity building just basically helps elevate that problem by equipping them with the skills that you might have been offering, and I'm pretty sure they'll do a much better job in dealing with the issue than somebody that's just come from somewhere. So the two youth groups that we involved were Malawi volunteers, and these were recruited from the African Drone and Data Academy. And also we involved youth living within the camp and around. So we're working hand in hand with the tech hub called Technolab, and our relationship and collaboration has been very helpful in making our project successful. So in terms of capacity building, we've trained 20 plus youths from the camp and also some volunteers from Malawi in drone technology. So we're training them on the basics of how to fly a drone and also how to process the images after they've collected their drone imagery. So this slide just basically shows the workflow of our project. So we used drones to collect the imagery over the Dzaleka refugee camp, and the imagery that we're collecting was about had a resolution of 3 centimeters per pixel. We needed this type of resolution because the camp setup is very congested, and if we didn't have the best resolution, tracing out buildings would have been very challenging for us. That's why we opted to use the drones. How we came up with AutoMosaic was using Pix4D Mapper. After we used Pix4D Mapper to come up with the AutoMosaic, we then uploaded the image to OpenAirMap so that we could then use it on OpenStreetMap to do the digitization. So before we even went to Dzaleka, we were supposed to acquire authorizations to fly. So seeing as to how Dzaleka is under Homeland Security and is a very sensitive area, we had to go to Homeland Security and get the relevant authorities to give us authorization. After they'd given us authorization, we then needed to go to the Department of Civil Aviation so that they give us the go-ahead to fly our drones over the area. Not only did this stop there, we then communicated with the field officers at the UNHCR office at Dzaleka to let them know about the project that we're conducting. And then from there, we did our data collection. So after the drone imagery and processing, we used the hot tasking manager to coordinate our volunteers on OpenStreetMap. And we used ID editor, or those are other people that are comfortable with using JOSM. We're also using JOSM to do the digitization of the relevant features from the imagery. And for the participatory GIS and collecting the actual points on ground, we use Kobo Collect. And the people that collected this data were residents at Dzaleka camp. We just walked them through how to use Kobo Collect, and they did the rest. We're now using QGIS to come up with the base map for the camp. And yeah, at this point, we're on that phase of our project. So this is just a snippet of the drone imagery that we collected at the Dzaleka refugee camp. I was hoping that this image would help you appreciate the congestion that I was talking about, at least on our bottom right. Okay. So as I mentioned earlier, I'm also a regional ambassador for Youth Mappers under the Aviation Maps initiative, and capacity building is an important pillar, at least for this program. So after my research, I realized that knowing drone technology, knowing data analysis is a very valuable skill. That's why I opted to then bring in drone technology workshops to the different chapters here in Malawi. So I've trained the Luwana chapter, which is located in Lolonge, in the use of drone technology, and also I just helped them in the basics of drone piloting. And I must say the African Drone and Data Academy has been very essential in helping me actually fulfill this, because they were able to provide the resources and the equipment in general, so that I was able to train my fellow youth in this technology. So the pictures here are just showing some of the training that we're having, my student on the left and myself on the right. So our training, the drones that we use for training are the S500s. The S500s are basically naked drones. You're able to see you're able to see the electronic speed controllers, you're able to see the flight controller, everything's out in the open, and you're able to appreciate the different components of a drone. That's why we opt to use the S500 as our training drones. The Mala Drone project is also something that we've worked on, and this is a project that was under the Malawi Leave of Welcome Trust project, and it was basically there to combat malaria, which is a serious problem here in Malawi, especially in the rural areas. And they worked with the ADGA graduates so that these graduates are able to now have hands-on practice and work on real-life projects. So we basically mapped 600 hectares, and we were doing this on a monthly basis so that they were able to assess some of the mosquito breeding sites. They realized that drones were an important tool in identifying the mosquito breeding sites that they wouldn't be able to identify otherwise if they didn't have an aerial view. So basically, Kasungu was an option because it's near the humanitarian drone corridor. Okay, and again, this is just the works. Yes.
Excuse me, we are running out of time. Will you please try to wrap up soon?
Yes.
Thank you.
All right. Let me just this is my last slide. So some of the lessons learned with being part of the drone industry and also working with youth is that collaboration makes the dream work. We team up as students, and we develop our own companies, our own organizations to actually tackle some of the issues that we identify in our communities. And also quick adaptation is very important, especially during the times that we're living with the pandemic. And also community involvement is very key in the success of our projects. And lastly, youth are very eager in learning new technology and their applications. But the problem now is that there are limited opportunities for them to do so. But I believe that as we go forward, people will be able to engage the youth more. Thank you very much. And I'm sorry for going over time. Thank you.
Thank you very much, Ndapile, for that very informative presentation. And we hope we have a lot of questions that are lined up for you in the breakout room. We move now to our next speaker, who is Hessel Winsemius, and the topic he's going to be presenting on is data collected by local people with local devices. How do we use that for flood consulting projects? At this point, I'd like to call on Hessel Winsemius to make his presentation. Thank you.
Yes, thank you very much. I hope that everybody can see what I'm presenting. Is it visible on your screen?
Yes, thank you.
All right, thanks very much. Yeah, this is not the first slide. Hang on, I need to go to the first slide. There we go. Yeah, this is it. Yeah, thanks a lot for the opportunity to say something about about how we actually use how I and my colleagues at Deltarus use the type of information that I think is really typically collected by this community that is actually listening to this this webinar at the moment. And basically, I want to thank. First of all, I want to thank a few people, especially Stephen Mather and Ivan Gayton, who helped a lot with the content on the slides that I'm going to present and the story that I'm going to tell you. And in the title, I have very specifically added local people and local devices, as I think that that is sort of key where you know a firm like Deltarus can actually learn a lot, do a lot, and really act in a much better and inclusive way by really taking care of these words and thinking about these words, local people and local devices. So I've concentrated a bit on flood consulting projects because that is a bit the space that I myself act in. I'm a hydrologist myself, and you know, a lot of the projects that I do have something to do with floods as the most prominent and most costly natural disaster related to water.
Hessel, excuse me, can you
yes.
make your slide full presentation? Because
you're not seeing my slides? Okay, hang on. I'm gonna.
We can see it, but like the properties, we can still see the properties.
Yeah.
Not
all right.
the
Hang
whole...
on. I will just stop share and then share my entire window to make sure it works. I guess this should work. Is this better?
Yes, we see it, but like that. Thank you.
Yeah. Okay. All right. So it doesn't mean that I'm speaking about flood that it doesn't apply to other natural hazards like earthquakes or landslides or droughts or others. But I'm going to focus on floods because that's what I'm doing the most in. So I think it's important that you understand a little bit what kind of firm Deltarus is before I say something about the applications that we work on. So we are, let's say, a company in a way, but we're also not for profit. I think that's important to recognize. So we are not in the world to make a profit. What we are in the world for is to develop knowledge and make sure that knowledge leads to impacts, leads to better decisions about, for instance, investments, also leads to better forecasts for weather or for floods, for instance. And therefore it leads to less loss of life and loss of property. And so we're continuously developing knowledge, and more we're starting to think also about how can we convey that knowledge and information more outside of ourselves towards a larger group of people internationally. Basically, if that we are not for profit basically means that we are not allowed to profit, but it does mean that we can go bankrupt. That's an interesting thing to note. So if we do very poorly in the market, then we can also go bankrupt. So we really have to take care of the work that we do. We're not a government entity or something like that. So we're based in the Netherlands, but and we do a lot of work abroad. So and more of that work is actually concentrating now in Africa and Southeast Asia. We have 2 offices in the Netherlands, and we have some regional offices as well in some countries abroad. So yeah, this is the type of work we focus on. And I'm not going into detail about these graphs, but I think that what is a nice, interesting thing to note is this little graph here. So what we really try to think through is also given that things develop in time, and it's not just sea level rise. Sea level rise is very important to my country because it's very low lying, obviously, but it's also about other changes in the climate, but also developments that are ongoing on the land surface because of people want to develop a land or other types of changes basically in the forthcoming or other goals that might appear. And we try to sort of think through how can we actually make water-related problems manageable so that spaces stay inhabitable also in the future for forthcoming generations. That is a large part of the work that we do. Now, okay, so let's now say a little bit more about what is a typical question that we need to address. So, for instance, a very important client for us is the World Bank. And I'm sure that also humanitarian OpenStreetMap team, you also do work for the World Bank, but you get different types of questions. And the type of questions that we address often is, first, we want to talk to a government, for instance, a local government of a certain city, about possible investments in flood risk prevention or flood risk reduction in general. Now, we don't know exactly what would be cost effective. We don't know, should we do something about protecting certain areas, or maybe think about reforestation in upstream areas so that much more water can be held inside the catchment rather than that it runs off very quickly and causes flooding. Should we do something about local water retention so that you reduce rainfall peaks? And then the question is, so can you tell us where the flood risks are and what they are, what actually constitutes that flood risk, what causes it? And then based on that, what are then sort of cost effective and also impact effective measures to take and where? And then can we actually manage also that this still works in the future? So that is a typical question that we need to address. Now, of course, you can already feel a little bit that what we need to address questions like this is data. And we cannot do anything without data. We are very good at creating models of the land surface, of how rainfall runs off to rivers and how then rivers transport that water and where then flooding causes. But we need data in order to make these models. We cannot do that at all without any data. So let's start with the first type of simulation models that we need for this, that is hydrological models. And we need to understand, in order to know how frequent and how severe flooding might become, we need to know, okay, how much water actually runs through these rivers during extremes, and how often does that occur? And we typically use rainfall runoff models for that. It's models that translate a certain amount of rainfall in how much runoff comes from there. Part of it evaporates, part of it gets stored on the land surface, and then a certain amount starts to run off. And then we, with long enough time series, we can also get a handle of how often do we get runoff that is really very high and may actually cause problems. Now, these types of models are very large in scale, and they are so large because they have to encompass a very large contributing catchment area that very local data is not often that important, to be frank. So to give you an example, this is a model that I worked on last week. This is a model for most of the catchments that encompass the country of Rwanda. And you can see that this is an entire model domain. Now, obviously, I'm not going to ask you to fly a drone over the entirety of Rwanda and its upstream areas because it's simply a too large question. And you don't need that kind of detail to make these models. What we basically need to know is which areas are actually running off. And you can see these areas all contribute to this river, and then that river flows towards this area, and this eventually goes downstream to the Nile. That is what we have to know. And you need terrain information but not in the kind of detail that drones require. Here's another example. We're also creating 7 hydrological models for a very large part of Europe. Also there, I'm not going to ask you to fly a drone over the entirety of Europe. Now, where it does get interesting is the next part. There's water flowing through these streams, and then at some point they end up in an area that is interesting for the client, that city that I just spoke about. And here we have an example of Dar es Salaam. And I really like this visualization very much. I really want to say thanks to Ivan for making this. This is the Zimbabwe River, And you can sort of see that the Mzimbabwe River has a certain capacity to carry water, if you like. And you can clearly see that here, that this is the natural levee of the Mzimbabwe. And when it exceeds that natural levee, then at some point water will start flowing into this area here. And also on the other side, it might flow into this area. And there's actually a neighborhood here, which means that you get into trouble. That is when you get flooding. And in order to know whether a high discharge event leads to flooding, we need to know this. We need to know how high are these natural levees and what is then the conveyance capacity for water in this stream. And for that, you need really accurate information. And that is where we, in this example, we work together with OpenMap Development Tanzania, where Ivan at that moment was doing the Romani-Urea project. And we hired them to collect survey information of these streams. So you can see these brown little things here. They basically describe the topography of the stream, including the wetted part and the dry part. And here on the right side, you can see how that was done. A locally manageable GPS device that is very accurate, really in the order of 1 to 10 centimeters or so, was used to really go across the stream and collect this information. And not just at one location, but also here in the back, you can see another one. And then there's another one over there, and there's more and more and more. So there was, in total, if you look here on the map, all these dots represent the cross-section. So they produced 80 cross-sections for us, and that is really sufficient to make a model schematization of this river, which can then simulate if a certain amount of water comes from upstream, how does that then travel to that stream, and where does it lead to flooding? So here's sort of the example. I, as a Deltarus expert, I know a lot about hydrology. I can tell you everything about hydraulics, but I am absolutely not in the position to collect this information at all. And there's two major reasons for that. First, I cannot travel to Tanzania, spend many weeks to do this survey because I'm sort of doing very different kinds of work. It's not my expertise, I would say. But second, and that is maybe even more important, it is not. I don't know the local context. I can't just travel there as a foreign person from the Netherlands and then go into a neighborhood and start walking through those rivers. I think you will get in very difficult situations if I would do that. So there's multiple reasons why I am not in the position to actually acquire this information myself. And third, and maybe more important thing, is that it is very well doable by local people if they have the right tools available. And this, together with Ivan, I did some student research also to figure out whether these more low-cost GPS devices that are very accurate can actually be used in a manageable way for these kinds of use cases. And yes, they can, and it delivers extremely good information for us. So we were able to really finish the job because of this data collection process. And now I have to go to the next slide. Yeah, here we go. And then this is a little bit what you get out of it. This is a map view where you see a simulation of that model that we created. So this is the Mzimbabwe. Here, all these cross sections were collected, and then our model is then capable to assess when does this river is this river not able anymore to carry all that water, and where does it then lead to flooding? And this is an example simulation of that. Yeah, and also, of course, in the surrounding neighborhoods. So the next question is then, where does that water go? And then that is where we need very high resolution terrain information, really in the order of 1 to 5 meters. I saw the previous presenter saying 3 centimeters. That is really important for orthophotos. But what we need is elevation information. And we need elevation information about a resolution of 1 to 5 meters or so. Vertically, it has to be more accurate than that. We really need to know where are the smaller obstructions that can hold water or make water flow in another direction. And therefore, like the vertical accuracy we typically need for this is like in the order of 10 to 20 centimeters. And also, yeah, water flows downwards. So you cannot have a terrain information that is sort of artificially bent because of lens problems. So if you have a very poor lens on your drone, then you also get it looks nice, the terrain information, but water will definitely not flow in the right direction. So that is also really important. And yeah, and no vegetation. Water doesn't flow over the vegetation; it flows under the vegetation. So we have to know the lowest level of the terrain that is there, where really the water flows. And the same is true for buildings. Now, and I think that UAVs can play a very good role there, because drones are getting affordable. And also, I saw the first speaker also mentioning OpenAirMap. There is free and open source software like OpenAirMap available to really tackle very large photogrammetry solution problems and deliver solutions in terms of terrain information. But then I think it's really important to say this, that there are a number of challenges also, and that those challenges are in the flying domain, but also in the processing domain. You need flight permissions. As I said, you need a good lens, which is really fit for purpose of terrain modeling. Even better if you have multiple lenses in different directions, that gives you more depth information. But lens distortion, like what you see here, this is supposed to be a flat terrain, but you see it's like a ball shape, and that is because a poor lens was used for this example. That is, we can't use that because then the water will simply flow to the middle while it is actually flowing over very flat terrain. The flight plan also needs to work for the terrain, and then processing for large areas, it can require a very large machine. So you should also be aware of that. And to really also correct for these sort of artificial terrain disformations, and to tie terrain to reference levels, you also need to collect ground control points, and that is also where the GPS stuff can be very useful that I showed earlier. Yeah, and then after you have a terrain model, then still you need to think about where are the buildings, where's the vegetation. So you might actually have to do a lot of digitization of that as well to eventually come up with a limited number of terrain points that describe the real bare earth terrain, which we need to understand where water flows. Yeah, another piece of information, I'm not sure how much time I still have, but just very quickly, what is also really important to us, especially if we're interested in local drainage designs, we often also do simulations on that. That's more on the neighborhood scale. Is like really these very local drainage structures. They have capacity to get rid of or convey local rainfall towards downstream areas, and then also really lots of details are needed to include those. What is the current shape? What is the size? Then we can also make a drainage model and a simulation model for that, and then figure out where are bottlenecks in this drainage and where should you increase the drainage capacity of existing drains, or start to think about building new drains. And we did something like this in Dar es Salaam. Actually, we thought about, Ivan and myself and the team in Dar es Salaam with Romani Huria, we thought about a good sort of data collection model. What kind of details should you collect and how should you collect that so that you really get the right information? And then a student of mine, Louise Peterson, she figured out how to then make a drainage model out of all those mapped details. But it's not easy. You really have to think carefully before you do your surveys. What information should you collect? How can we make sure that also lines, drainage lines are connected to each other, so that also the models that we generate with it understand that water doesn't stop flowing but really goes to that next drain. Before you really start doing your survey, you should really carefully consider that. Yeah, and finally, this is a bit what I think we should move towards, is that the connections with satellite information, I think, are really, really very interesting to start exploring. And I think there could be potentially great value in use cases where local surveys are used to understand better what a river looks like and the floodplain around it. And then you can start to assimilate to that information. You can start to assimilate lots of satellite information, which then gives you information about what the river flow is. So imagine you really know with what depth do you get what width, because you have satellites that can measure the depth of a stream, and then you can also, if you have the local topography, you can also derive the width, and if you have the slope, you can also make an estimate of the river flow. And sometimes you have a depth, sometimes you have a width. Eventually, you can start to convert that into river flows, and we're working on that with many students at TU Delft at the moment to figure out how to best do that and how to combine local ground surveys with satellite data to acquire that information. I think it's crucial simply because river flows, it may seem a bit of a very local thing, but it's basically one of the only things you can measure in the land that integrates all the impacts of climate change over the entire upstream area. With rainfall observations, you cannot do that because they are a point observation. A river basically collects rainfall over the entire upstream area, and therefore is one of the sole integrating things you can measure to really see what climate change does with the land surface and the response of the land surface to rainfall. So yeah, my lessons, I would say that the lessons that I learned myself is that, yeah, first of all, local observations, super valuable. There's no doubt about it. And I've given many examples of that. I gave examples about flood modeling, but also, of course, the information you need to understand the risk also involve where do you have houses? How much are they worth? How are they built? Are they vulnerable to flooding? Yes or no? All these bits and pieces of information are crucial to understand flood risk. But I also learned it's not evident to get it right. And I think that is really important to also to convey to you. Terrain, it must follow the real terrain on large scales. Otherwise, if you make hydraulic simulations, simulations that estimate how water flows over the surface, they will be very wrong. They could actually point water into the wrong direction even. Profiles require detail that you cannot capture with a smartphone's GPS. You need more accurate GPS positioning abilities, and we have that now, and affordable. It's not expensive. It costs a couple of $100 and you can actually do it. Of course, you need the knowledge how to do it. That is the second thing, but the cost for the materials are not a threshold anymore. Yeah, important to understand water flows over the lowest point. So except when it's on an aqueduct, that's the only case where it doesn't flow on the lowest point. So you need bare earth terrain for our work. So just a terrain model that comes out of your photogrammetry is not sufficient. You need more processing. And finally, I think this is the most important thing. What I learned is that by talking with OpenMap Development Tanzania and being there and discussing, that is where you where you start to understand each other. First of all, I understand what the abilities are, but then also an entity like yourselves can understand what we need. And I think that is where that sort of interaction between domain experts and data collection entities is crucial to get it right. And ask yourself the question, if somebody asks you, I want to have a data set from you, always ask the question, what are you going to use the data for before you do any survey and any mapping? That is what I recommend. Thank you.
Thank you very much, Hessel Winsemius, for that in-depth presentation. At this point, I'd like to announce the breakout rooms that we have for this webinar, and you can all participate in the breakout rooms in order to have in-depth, in order for us to have in-depth knowledge from the speakers. We have the breakout room 1, which is the drone data collection, and the panelist is going to be Ndapile and Taichi and Ndapile, and then the facilitator is going to be Angela, and we have Geoffrey who will be with us in that room also. And also we have room 2, which is the drone data usage, and Hessel will be in that room and is going to be facilitated by Victor. And Anali is also going to be part of that room. So the breakout rooms will pop up soon, and then you select the one that you like to join.
John?
Yes?
Yeah, so you will be the one to wait here, or yeah, you can join the breakout room since, yeah, you'll be policing. Okay, and Do you have the ability to close the rooms, or no? I think that's only me since I'm the
Our
I'm the one.
co-hosts can close the rooms as well.
Can?
Yes.
Okay, so yeah, please close the room at 13:28 UTC. I mean, I think it will show like a 1 minute and we will be closing. So okay, yeah. So I need to go to the breakout room too. So see ya.
Okay, bye. Okay, for those of you who are still in the main room, just feel free to go and see the breakout rooms, room 1 and room 2. You can just go the breakout rooms menu below the window. Okay. Hi, Tommy. Are you here?
Yes, I'm here.
Okay. So I'm about to close the breakout rooms, and most probably there'll be a countdown, and then people will join back to the main room.
Okay.
Okay.
Welcome back, everyone.
Welcome back, everyone. Thank you, everyone, for joining us. Okay, I'll pass the mic over to Tommy again.
Yeah, I already did the welcome back. And thanks very much to our speakers, Taichi, Ndapile, and Hessel. And we'd love to hear your feedback. Please follow the link that's on the screen, get in touch, and we'll definitely make sure all your questions or interest will be properly attended to by our speakers. And hopefully we'll have more sessions like this next year during the course of 2022, and we'll definitely keep in touch and make the necessary announcements when it needs arrives. Thank you very much again, and you all have a good day and good time depending on where you're watching from. Thank you. Before we leave, we'll want to have a group photo, so we'll advise everyone to switch on their cameras, their webcam, so we can have a group photo.
Okay, great. Going once, going twice. Last, everybody smile. Great, thank you so much.
Thanks for attending.
Yes. Have a good weekend, y'all.